we need to get into a new paradigm where we understand the resilience of having topsoil in place. And that is the real food, actually, at the end of the day. That's what actually is the battery charging up your trees, basically. It's like, without that, what can you achieve? I'm Milan, and I'm originally French, and I've arrived here at Daniela 3.5 years ago. I did a permaculture design course for a month here, and then a few months after, I ended up volunteering here for about a year. And now it's been about 2 years that I actually work here. And yeah, this entire process of doing this permaculture design course really got me into more of the sustainable agricultural practices, which I didn't have any knowledge of prior to that. And I really found a fascination in the living processes, in like the way that trees and plants just grow and are never in a static state. And just seeing that is a really thrilling experience for me. And also like growing your own food in a society like ours, modern society, it's really, I think, important for me, because I just can't find the quality of food that I would like to have in most places. So I find it really important to grow my own food. So to simplify Syntropic Agroforestry in layman terms, I find that it's basically utilizing the processes Mother Nature has to create a forest. And by utilizing these processes and by understanding them and implementing them, we can increase fertility in a given spot, and we can also have crops that are put in that spot that perhaps before the succession of the land, of the soil, would not actually allow these plants to really thrive. So by utilizing the other plants that are going to be more supporting, you're going to actually allow the succession of the soil to increase. And it's basically, we're getting in a sort of upward spiral of like more diversity and more fertility that actually attracts more biodiversity, better crops, more abundance over time, which is just the exact opposite of what we find in conventional agriculture. So the thing is, it's really relevant to nowadays, because a lot of our topsoil has just been very depleted in a lot of spots all over the world. I don't know exactly the statistics, but there's definitely been depletion of these topsoils. And by utilizing this technique, I think this is one of the fastest ways where we can get topsoil to come again, and we're able to really create a deep amount of topsoil with this technique, utilizing the plants and processing them by pruning them and then cycling them onto the ground, which will then allow for plants of higher succession to actually take space in that spot, which it couldn't do that before. So see other plants that were there that actually nursed these other plants that need more fertility. So that's the way nature really creates a forest. And by utilizing the plant powerhouses like, let's say, eucalyptus or castor oil or plants like that, we are really able to increase like soil conditions and biodiversity and abundance of crops. So in conventional agriculture, the thing is, there's definitely a notion of maximizing photosynthesis. It's really important. If you look at the cornfield or wheat field, it's really important to grow as many plants there as we can. And with that photosynthesis, like the power of photosynthesis makes a crop then available. But the thing with conventional agriculture, especially with annuals, is that we just cut these plants and we actually take off all the fertility of them. So let's say, for example, when you grow wheat, we just grow the grains, and then all of the biomass of that grass will just be taken away and then fed to animals or brought like 100 kilometers away from here. So really we are depleting soil over time, especially with tilling. Whereas with Syntropic Agroforestry, we try to minimize the tilling. It's really important when you set up like an agroforestry line, not for veggies, but let's say tree lines, orchard lines, what we want to do is just till the soil once, and then we trust that the plants are going to improve the soil so much, the structure of the soil is going to be so much more increased that it's going to allow for these crops to really thrive. Whereas in conventional agriculture, it's just like you got to till again and again and again, and by doing that, you oxidizing the soil to the natural processes like wind and like sun. So really, Syntropic Agroforestry aims at maximizing photosynthesis as well, but over a longer period of time. So it's not plants we end up ripping out of the soil. Like plants are more long term, like trees. So we use more trees and perennials. But obviously, we can also grow annuals in between lines. And by utilizing the biomass from the trees, from the grasses, we really able to create our own compost in the place. So really, Syntropic Agroforestry really aims at reducing inputs. I mean, in some spots, it's impossible to completely eliminate external inputs, but we aim to use as little as possible of them. We try to grow the trees and the biomass in place that then will increase the conditions and the fertility, being basically our compost in place, in situ. So you could say as well, like, it's also very different than, let's say, organic gardening as well, or permaculture, in that respect, because I find in these practices, there's a lot about bringing in some really good quality compost and things like that. But the reality is, when you take compost from another place that could have received that fertility and bring it over to another place, we are like depleting that other land there. Whereas if we grow the plants for the biomass for the compost here in place, we're really able to keep that fertility where it is and not bring it over somewhere else. It's really important to do that for resilience, because we can't guarantee, especially in a climate like ours here, in a semi-arid climate, compost is a very scarce resource. We don't have much wood. We don't have much biomass available to really make this compost. So it's really important, especially in a climate like this, to utilize what we have in place. It came from Ernst Götsch. It's a Swiss plant genetic researcher that he really came to the conclusion that rather than trying to breed plants to be okay with the bad conditions we give them, he would actually give them the better conditions in the first place. Why are we putting so much effort on them being okay in the bad conditions, when really the problem at the root is the bad conditions of the place? So why not improve the conditions of the place for these plants to thrive? So it's a really interesting thing, and he actually inspired himself from a lot of indigenous cultures, mostly from the Amazon, because now there's a little bit of data coming up saying that basically the Amazon might have been a man-made forest. So in some sense, it was humans utilizing a similar technique, where they would basically make an opening in the forest that then they would grow crops into, because there was so much shade in the tropical rainforest, you couldn't really grow anything in there, maybe a few fruits. But if you really want to control what you're going to grow there, like, you got to open it up. And they did that, and then after the crops have grown and all that, they will let the forest to actually like regenerate itself. There'll be plenty of seedlings in the seed bank that would just definitely take over on the long term, and they would just utilize all the biomass of making that opening for actually growing their crops into. So he heavily inspired himself from that. And there's other indigenous cultures, like from South America, from Asia, from Africa, many different places. And yeah, he just utilized that, and then he ended up actually buying a big farm in south of Brazil, in Bahia, and he ended up making one of the farms that was the most depleted here, that everyone was saying, like, you can't grow anything on this. And over time, over the 40 years he's had the farm, he's been able to really improved the conditions so much that he's now able to sell the best cacao in all of Brazil. So, and there's other things that have happened too. It's not about only the crops. Like, he's really created an abundance of it. The forest is really abundant now. It's a lot of organic matter. And also, I don't remember the exact number, but there's a number of rivers that used to be not even running anymore when he bought the farm that ended up running again. All of them run again because of that, because he restored the water cycle as well. So it really showed that it worked to deal with depleted lands. And then there's been a lot of people, a lot of his students that have been continuing that since. So there's really 4 principles I can identify, make it more simple. I would say that first is succession dynamics are really important. It's really about understanding the place in the succession according to the soil of the plants that we're using. It's really important to realize that, because we need to deal with the conditions that we have. We don't want to put in plants that require too much fertility when we don't have that at the beginning. Or we can have them, but they can be nursed by other plants that really need to nurse these other plants. So succession is very important. It's something I find that you don't talk enough about in at conservationists and all that. They don't talk that much about succession, and I think it's a really important thing to realize, because it's same with crops. Like, when you put a crop in place, you shouldn't be putting it in a place that requires so much inputs to really have them thrive. We want them to thrive in the place where they're at, or we want to improve that for them at least. It doesn't make sense, for example, here to plant an avocado. It doesn't make sense at all. We don't have enough water, there's not enough fertility, and there's frost as well. It's just not the place for it. This is a really important part of it all. I think it's one of the most important parts, actually. Because we just deal differently with soils, let's say, that have like bedrock only 10 centimeters after the soil, or with other ones that have, like, I don't know, 50 centimeters of topsoil. I mean, it's just very different way of dealing with these places. And I find the more you have a depleted place, the more it makes sense to be using this technique. But the more fertility there is in the first place, and the less sense it makes to use that technique, or you could just reduce the density. Then second principle I would say is about stratification. So we're using plants according to their needs of light. It has nothing to do with height. It has to do with light. So there's like 4 different layers we say in the forest. So there's like the low strata, the medium strata, the high strata, and the emergent strata. And it can be much more simplified than that. We can make it into 3 stratas if you want. But basically, the idea is that there's certain plants that are very shade intolerant and that grow up tall, like in a pyramidal way. And these ones, we can use them to be at the very top of the system. And then there's other plants that are a little bit lower and a little bit more of a like bushy canopy that we call like more high strata. So, and then we have more the medium strata, is more bushy plants that are going to be like more on the soil, but not completely. And then we can leave the low strata plants are going to be the ones that are going to be more closer to the ground, that are shade tolerant. Because, like, don't get me wrong, there's a lot of plants here, especially in the Mediterranean, that, like rosemary, let's say, this is definitely not low strata. It needs a lot more light to really thrive. It's not a place that it doesn't enjoy the canopy of a forest over it. So I can give you a few examples of that. So basically, we have usually it's the eucalyptus gets used a lot as an emergent, and then you can see below it, for example, in our conditions, we could use the false pepper tree. As a medium strata, we could use, for example, the myoporum. It's a really nice bush plant. And then as a low strata here, for example, we could use the viburnum tinus. It's a plant that is native to here that enjoys shade. But yeah, it's a little bit tricky because it depends really of your place, of your conditions, your climate. Because I find really in the Mediterranean climate, it seems to be more sort of like 3 different layers rather than 4. There's very little plant that can really enjoy the full shade that it would in a subtropical climate. So this is an important thing. It's really important to identify these plants and what strata they are. So by doing that, we can also maximize photosynthesis. So the idea is that rather than like normal like orchards or forestry, what we want to do is increase the photosynthesis rate to 200% of what it is in these practices. So what we end up doing is that we have our emergent layer that is above but doesn't take too much light, because it is not enough light for the other plants below. The plants are not going to make it so well. So we want that. And then as we go down towards the ground, towards the low strata, we want more and more density in that. That's the idea of stratification. And really, the third principle, I would say, is disturbance. It's a very important thing. So nowadays, you don't really realize that, because I find a lot of people are actually very afraid of like cutting trees. They think you're giving harm to a tree, and we can see that a bit in the permaculture scene. I can see that happening. But the reality is, like, plants have always been disturbed. And by disturbance, I mean, for example, it can be a big storm. It can be megafauna, like a bison or European rhinoceros or things like that, or mammoths or whatever it is, or deer or moose, things like that, that really end up like nibbling on the plants and end up even like doing very strong disturbance. And we don't have these species anymore, at least in Europe. We have very little of them. Like the only one I can think of now would be like wild boar, for example, or deer. But we used to have much bigger animals that would really bring in like disturbance in forests, and that was very, very important, because when we do that, we allow a lot of things to happen. So in a forest, we allow more of a clearing to happen. Let's say an elephant goes in and rips apart a tree. By doing that, it really allows the light to come, and it allows the nutrients to be cycled. That's a really important thing, because nowadays it's very difficult to actually, like nature here, it's really difficult with the animals are here to really create that disturbance that is going to allow more of this cycling of the nutrients. Also, a sort of growth pulse happens when we do disturbance, which is basically we cut a plant, we cut like a long line of plants, let's say, and then actually by pruning, they become more vigorous. So let's say a plant is in a state that is just in a stagnant state, but by pruning it and by pruning all the other plants around, we really allow these plants to regrow very vigorously. And it also makes a lot of sense in terms of like the reproductive cycle of the plant. Because if a plant does not receive disturbance, it can put all its energy into seeding, which to some extent we want that, because we want a seed bank to establish itself. But we don't want that to happen too much, because then it's all the energy of the soil can be used for these seeds to be created. So disturbance is really important, and especially in this part of the world, we need to realize we need to be the ones doing this disturbance. Like no animals is going to do that naturally, or if they do it, they'll make something very destructive, like wild boars you can see here. So really by pruning, and with a way of pruning as human beings, we can do a very clean cut, which really allows a regrowth to happen much faster. Whereas like if an elephant terraces a tree, it just like takes it down completely, and then there's no opportunity for regrowth. Or if a storm like just breaks branches, it might take a little bit longer for the plant to resprout from that. But really we need to get back in touch with that, because it's extremely important. It's really an important thing in the ecosystems to have these plants pruned, and as we say, we call it disturbance. And that touches on to the fourth principle, which I find is utilizing the process of mycorrhizae. Like it's basically the root association between plants and fungus. So basically, we need to understand it's a little bit difficult to get in touch with that, because it's something happening underground. But basically, it's the mycelium in the ground that connects all the roots together, that will actually, via that, it allows this sort of growth pulse to happen, as I'm saying, because then these plants are all connected. And basically, when they're being disturbed, what happens is that they can send messages to each other via that, and they can also upcycle certain nutrients that they wouldn't be able to have because the fungus makes these nutrients available. And really, by the message that they send to each other is like, oh, I've been pruned, like be ready to be pruned and be ready to grow vigorously now, because you've just been, you're about to get pruned really hard, like if a storm happens or something like that. It's like really important to understand the intelligence of these plants utilizing this mycorrhizal association. So really, it makes us think that it doesn't make any sense to plant, let's say, a tree alone. We really want to plant trees together, and that's what happens in nature usually. It's like a plant is put in place like a pioneer, then other plants around it will end up taking the space around that plant and then take over the succession. And yeah, it's just very important to get back in touch with these four principles. It's very adaptable. It depends of how you just got to make your agroforestry according to your context or what you want to grow. But in terms of, I can touch more on the support species part. It's really important to put in plants that can respond really well to pruning, because then we can get much more biomass of them. We can offer much more of a growth pulse to the system. And yeah, I mean, it just depends. You just got to lay the plants. It's more the combination of plants that matters in some sense. But yeah, definitely it's not a good idea to put in plants at the beginning, like pioneers that will just go really slow, because yeah, that's just not gonna work so well. So you need to be able to identify in your place, on the roadsides, in the forests, places like that, what is really growing well here, and what grows fast. That's really what matters. I mean, definitely there's going to be some trees that are going to go slower in the future, like the more later succession plants. Of course, there's some of that, but really we need to have the plants really synchronize with each other. So it's really important at the beginning to have these fast-growing species, and then later on, the slow-growing species can be below the nursing plants. But think about it. The topsoil you're going to create with a faster-growing species, it's going to happen much faster with a species that is a real powerhouse compared to, something that just goes really slow and doesn't respond really well to pruning. So, most important, I'd say, is just the response to pruning and how fast they are. I would identify 5 steps. I think the first one is really getting accustomed to the plants around where you are, the plants that you think of using, and maybe if you have some available, start pruning them and seeing how they will answer. And I mean, obviously, there's a lot of people that have done the work before that you can get inspired from as well. That's really important to find that. But I find that really getting accustomed to the plants, that's the first step I took. And I just went a bit ballistic with that. I just ended up like, any plant that I wouldn't know, I would just go and identify it, and then go and prune out some of them. You can maybe prune out some in the wild, or you can prune out some that are in at your place, and then just come back to that place after a few months, see how much they've regrown, and etc. I mean, I think this is a really important step to start with anything, because sometimes we just have like a certain idea in our head that, oh, this plant's really going to make it here, but it might not. So it's important to really start understanding that. And then the second step would be designing. So there's different ways you can design that. It depends on your goals, obviously, but utilizing these plants that you know are like powerhouses, you can then make up a design with that just by understanding the stratification, where they fit more or less. Doesn't need to be perfect, but designing in a way that makes sense and is systematic is really important, because if you plant just random trees here and there, it's going to be very difficult to really manage after. It's better to use plants that we can see it's quite systematic, like, I don't know, eucalyptus every 5 meters, or fig every 5 meters, things like that, that's a really important step, I'd say. But obviously, designs like evolve over time. With the more knowledge you have and the more management you've done on these systems. Then the third step is planting. So for planting, it's important to understand the succession of the land. It's really important to understand how rich the soil is. Can you do that system without any compost? What plants you're going to use for that? Do you have like good fertility so you could just plant straight away in that and not even add compost? Or maybe you want to just add compost to just your fruit trees, let's say, or just your crops are growing in between. Got to understand that. Also, another one that I found really important, and it's something we might not realize in the Mediterranean climate, because a lot of people are talking about, that you basically just till the soil and then you can plant straight away in it. But that's been tried here before and it didn't work because we have a very compacted soil. So we need to understand the drier the climate, the more it's been tilled, the more it's important to do a proper soil preparation. So we could use a subsoiler, we could dig a hole much deeper. I mean, there's different ways we can do it, but it's really important to identify it, which way you're going to do it, and doing it in the way that is the most efficient and that at the same time will offer the maximum amount of results for the least amount of time spent and the least amount of disturbance, the least amount of inputs, if you can. It just depends of the place, really, and it depends of your context. Maybe you want to put loads and loads of compost for it to grow much faster. Maybe it's just about having a living hedge as soon as possible. So maybe it makes sense to do that. It just depends of that. Then, really, the fourth step is managing. So over time, you gotta get used to managing. We don't realize at the beginning that the amount of management that is involved, because we really need to prune the plants to allow that growth pulse to happen and allow more light to come in for your crops and for the plants. It's really important. The management is really important, and we need to start thinking that, it's really, the Syntropic is basically 95% management and 5% planting. So there's going to be much more time in managing than in planting, which is only natural because these systems are resilient over time. So it's not just for 1 year. It's like you got to do that over the entire course of the succession plan. So it's really, really important to take that into consideration. The management is really important, and the timings of when you're going to want to disturb is really important, especially as the climate gets drier and drier, like it is here. Really important to understand when is the right time for doing this management. It doesn't make sense, for example, to do that in the middle of summer. It doesn't make sense at all. Maybe certain plants can handle that, but most other plants will not like that at all. So, and the fifth step really that will add to that is listening to the succession that's happening. So there's something that plants are able to tell us when it's really their time to thrive or it's their time to go. Like we can see that happening. And if there's another plant higher in succession that really wants to take over the space, and then there's this other plant above it that is starting to become stagnant, starting to be, infested by fungus, disease, insects, things like that. It's things that you see along the way. It's like not something set in time. It's difficult to really plan out these things because you might get a fungus infestation on a certain type of plant that you wanted to have in the future. But maybe in the future, a bird plants in that tree, plants in another tree that ends up being much healthier, let's say. But you gotta be able to listen to that and act according to that. It's really going with the flow of nature in that respect. You can't just impose your way on it, I find. There's a lot of surprises along the way, that's for sure. So really listening to the succession is a very important part of it in the future on a more long term. So that's five steps. Well, the thing is, mulch is basically increasing fertility in the place. But not only that, it also increases the moisture that's going to be available here because it just protects the soil from drying out. And it has different benefits, like it can regulate the soil temperature, can increase the fertility, it can keep the moisture in. And we have to understand as well that biomass, we mostly think of biomass as something happening above the ground that we prune and then we get the biomass. But biomass happens as well. Biomass release also happens in the soil via what we call root exudates. It's the shallow roots of the plants that um, end up. Yeah, I mean, some of them, for example, if you look at a plant that has died and then you leave the root in there, and that's going to decompose over time, opening channels for other plants. But it also creates biomass in that place. So there's some of that to it too. And I think that biomass in the ground is actually very important and can be sometimes even more important than the biomass that we get in the air and that then we prune and put back. Because think of it like big trees are just being cut and then another plant is to take over in succession. I mean, you can imagine the roots could be very big, and if they decompose and all that, they can just be really good for increasing the fertility. And same, I mean, it attracts more insects, more bacteria, more fungus, things like that. Just it's really important to use the biomass, even though it's more like of a byproduct of the managing the place. So yeah, it's a very important part of it to increase the topsoil. So I can identify three of them, like generally. So the first one I would say is more like when it comes to big picture thinking. So really, we need to be thinking that it's a difficult paradigm shifting practice. A lot of farmers are just not used to that. They don't understand that. They would even think that too much plants like that could be competition, for example. And they also need to change their way of thinking in the sense that they need to stop thinking in terms of like cash crops and then like just getting as much of the land as possible without returning anything to it. And that we see a lot, cultures of wheat and sunflower. Here, for example, they burn the sunflower stalks that could be used for biomass. They, of course, take away all of the wheat, all of the hay away from the land. So, of course, over time, the soil becomes worse and worse. Even with the soil that has a lot of fertility, over time, it's doomed to really get worse and worse. And erosion, all that, keeping bare soil. I mean, it's very paradigm shifting, and it's also very difficult for people to understand that this can be a system that can be efficient. And right now, it's true that we have challenges with that, proving it can be efficient. But really, it's about changing your mindset and being like, not what crops can I produce this year, but what crops could I produce over time that actually are going to get better and better if I continue like feeding the soil and I give back to the soil. So in some respect, it's very difficult with the factory farming that we have right now that doesn't allow. It's like basically not. It's a factory. It's not a farm anymore. So we need to be thinking of how we can get more this regenerative approach. And it's not just about conservation of nature. It's about really understanding that topsoil is what feeds us. It's a really important part of that. And over time, I mean, it's going to happen naturally. What's happening is that the less topsoil we have and the less food we can produce. And it doesn't matter how much fertilizer and all that you end up putting on it. At some point, these factory systems will fail, and they're already failing in many places. So there's definitely that to it. Another challenge I find is more detailed, like small picture, is basically we need to set up systems that are going to be just efficient, and we're going to be able to manage the light between the plants. This is something that can be a little bit more tricky because it's more of a timely management than, let's say, an orchard, because you really need to prune the support species, let's say the emergent layer, to allow the fruit trees below, let's say, to really fruit well. And if we do it at the wrong time, it can produce problems. So it requires more knowledge. The only input in that is basically knowledge. There's no other external inputs. Everything just comes from inside us, and we need to start understanding these processes. The third technical challenge is going to be to make it efficient and practical, because definitely one thing that can happen with these systems is when we make them really dense and so much diversity, it becomes difficult to actually be efficient in managing. And yeah, I mean, it can make much more sense, for example, to do rows of just one crop in between rather than having to stratify everything. It just like, no matter what, it's still going to be syntropic in some sense. It doesn't need to be all stratified. But we're using and we inspiring ourselves from this practice. It doesn't need to be all syntropic and super diverse. It's like, it's just important to utilize the processes I've talked about, and yeah, just make the management as efficient as possible. Maybe it makes more sense to just make a row much wider. Let's say, for example, for, I don't know, the tractor to pass by, make the space in between the tree rows like the size of your tractor, basically. So if you just cut grass in one cut, and it's enough, you don't need to go back to it or anything. So things like that are just very important, and we need to see according to your crops. Because, for example, if you look at olives, if it's especially for oil, it's a bit difficult to end up like harvesting in such a system with so much density, because usually the way of harvesting is they all fall to the ground on the top, and then we collect them. But so it's very difficult. There's a lot of plants around, so we really need to take that into account and understand that, yeah, it's got to be efficient because it's got to be profitable as well for the farmer. That's a really important part that it doesn't get touched enough on with the syntropic, because most of them are more smaller systems. But if we want to make it productive, if we want to prove that it works, we gotta make it efficient. We gotta make it practical. There's a lot of ecological benefits to it, and I wouldn't like start enumerating them all, but I think I can identify about 5 of them. So the first one is really topsoil creation. So a thing that a lot of conservationists don't understand is that biodiversity is linked to the amount of topsoil that we have. We can have much more biodiversity the more topsoil we have, because there's more trees, there's like more higher succession plants, there's more bacteria, insects, fungus, like all that biodiversity there is really, biodiversity increases basically with the amount of topsoil created. So in that respect, via the process of topsoil being created, there's a certain amount of carbon sequestration that happens. Like all the carbon goes back in the soil rather than being released to the atmosphere, which is just not a natural way that it happens. Like if I had tilling, usually that's a way that it can happen, the carbon going back to the air. So via these techniques, we actually store the carbon into the soil, and then you can just sequestrate that carbon. Another benefit, I would say, is like restoring the hydrological cycle, the water cycle. So it means that basically via all this density, the moisture can stay much more into the soil, and that can allow the aquifers to recharge, because it allows the water to infiltrate better. So there's definitely that part to it, and there's also like the dew that gets on the leaves of the trees. There's actually much more water being created with the trees, and Hans Gutsch has proven that on his farm, that basically it can attract more rain above a certain space. If you do that above a certain space, it can actually attract more water there. It can attract clouds to come here, because then the water has to fall where it needs to fall, where the trees are, and then that allows the aquifers to recharge. The third one would be erosion control, which really has to do a lot with water cycle, but it also has to do with nutrient cycling, that it doesn't just flush away. So erosion control is just very important. We have a lot of eroded land, especially in dry climates. When you look at it, when the first rain happens after the summer, what ends up happening is that a lot of the soil ends up washed out at the bottom, because there's nothing to cover the ground. So ground cover and trees and grasses especially can really contribute to erosion control, that's for sure. Fourth one, I would say, would be food being created for the wildlife. I mean, of course, the most important part of that all is to create food for yourself and your family and people around you. It's really important. But also, I mean, it can also be made for birds or for wildlife to really have access to that, to berries that even ourselves wouldn't be able to eat. Or like, for example, you look at, let's say, a mulberry, for example, that can attract a lot of birds. And yeah, it's food for them, and it's food for biodiversity in general. It's food for the fauna and the flora. It's also it's food for the insects, like all the biomass, all that wood decomposers. They love it. So that's really important part. But that just basically all comes together. So this is something that doesn't get touched enough on, and I can see definitely conservationists like not being happy about what I'm about to say. But basically, the thing is, species or exotic species that are considered or deemed invasive, these plants can actually have a very important effect in restoring the local biodiversity, because these plants are adapted to a certain condition of the land that maybe other plants would not be adapted to. So maybe other plants are adapted to it, but they don't have the same amount of biomass that they can offer, the same amount of recovery after disturbance that they can offer. But with these plants, sometimes what we end up finding is that we see below these plants a lot of plants that would not be there if there wasn't that plant in the first place. So we can see different plants, native plants, or like of higher succession being nursed below these plants, and these plants are going to take over much faster than if they are below another native plant, let's say. So really, it can have enormous benefits to that. And I think with Syntropic Agroforestry is really important, in my view at least, that in the later succession stage, maybe in the first succession stage, we'll have a few natives in there. Because some of them go fast, but then really on the long term, it's really important to utilize species that are more native, that actually are very adapted to the place, and then they can recover pretty fast after disturbance once the conditions are better. So for example, we can think of the Celtis australis, the hackberry, we can think of the ash like I have here. The plants that I would really like to see take over in the future. I think it's important, and yeah, it can basically, via inspiring ourselves from that, we can really figure out a way to restore native biodiversity. And I mean, to some extent I haven't investigated that, but maybe some certain plants that are maybe not native to here, you could see certain birds that will start eating them, start to adapt to it. And yeah, I mean, I've seen that in New Zealand, for example. Like, there's been a lot of gorse taking over in a lot of places, but really what we see is like they want to just spray it, they will just want to kill it, but by doing that you're just making the soil worse and worse. I mean, then you're not letting the native species really take over. But sometimes we can see in the midst of that gorse like just native plants coming out of it, and they do so much better than if they were in just bare soil. They just wouldn't make it. So really it's important to utilize the succession, even with plants you're not happy to have in the first place, even if they're not native, exotic, invasive, to utilize them to really boost the plants that, yeah, I mean, are not going to make it if in bare soil. It doesn't work like that. And I see that a lot in conservation projects, just planting in species that's just not adapted to the succession. And okay, it will survive, but it takes forever to grow. It doesn't grow as healthy as it should. So yeah, I mean, it definitely has very important consequences for the native biodiversity. And we're talking about birds, we're talking about bigger animals, all of that. Really also trees in general, like they allow in a given space for grass to grow better, which allows more of these different prairie animals to just basically have more grass available to eat. So there's a lot of things, and I cannot touch on everything. Yes. Well, anywhere where something grows. I mean, of course, you can't do that in Antarctica. Or, yeah, I mean, it can work from deserts, from like hot deserts to subarctic zones. It works anywhere because it's the same principles. It's the same succession. It's the same way topsoil is created. In all climates, it's the same. It doesn't differ. So, of course, the strategies are going to be different. In a desert, definitely you need to bring in water. Like, I mean, very little plants are gonna do fine without water there, especially. But like in subarctic zones, you need to also take into account that the growing season will be much shorter as well. So there's only few plants that are adapted to that. There's going to be less biodiversity, that's for sure. Because the plants haven't really evolved yet to actually work so well in subarctic zones. But there's always going to be something working, and it's just like just finding plants that are really adapted to that. And of course, it's going to take longer in the desert. That's for sure. In a hot desert, it's going to take much longer in a subarctic zone, but it's still going to work. It's still going to work better than if you're not using that technique. I would say that just be open to start. Like, don't linger too much with the theory. Really get on with the practice, because that's the real thing that is created. I mean, you can't just do that via theory, by studying and nerding out on things. You really need to practice it and try out the plants. Try that. Have no prejudice towards the plants as well, because that's one thing that I definitely see being a problem. It's like, oh no, I don't want to put this plant because I don't like it, or because other people don't like it, or etc. It's like, no, we gotta be able to. For me, I would see if a plant performs the best in that condition, use that plant. If other plants are like don't thrive as much as this one, I mean, why does it make sense to use that other plant? No, use the plants that work. And I mean, it's just like, it's a lot about practice. Actually, just one advice I would just say is just do it. Just do it. Don't. You can still study during the time you're doing it, of course, and you have to also listen to the system. Really listen to it. Don't like impose your way on it. So, but the first thing you gotta do is just do it. It has the potential to develop way more than the state it's at now. I could imagine more intercropping happening. I could imagine more animals being integrated in it. But for that, usually you need to do more larger scale plantations. I can see much more larger scale plantations happening. But again, as I'm saying, we need to deal with that challenge of like, we need to make it practical. We need to make it efficient. Because if we don't make it efficient, if we make it overly diverse and it's very difficult and it takes a lot of time for management, how are people going to even adopt that technique? They're just going to think it just takes too much time and effort. And it is what it is. Like, we got to think, like, when we think of a syntropic system, it's got to be something that actually evolves of itself towards a higher succession. And is like, the thing is, wasting your time on something that takes too much time can be an entropic process. So the opposite of syntropic, meaning that we end up actually not supporting the place, because the human being is as part of that system. And if the human being is part of that system, we need to take into account the economics of it. We need to take into account the financials of it. We need to be able to make it profitable, or this is never going to continue. So it means that you won't be able to actually restore the land and have your crops and all that and create that abundance if you don't get something out of it. So it's really important to take that into account. And I think that this is going to be, it's going to come to fruition like soon enough. I mean, there's already farms that are doing that. So I find that, it's just really important to take that into account, because we're not gonna, it's also about feeding people. Like, it's really, agriculture is about feeding people. And that's the most important thing. And if you can only produce a little amount of food for the amount of time you spent, how's that going to work? So really, more animal integration, more intercropping in between. I mean, it depends on the climate that you're in. It can be difficult. But I think that animal integration is a really important part. Efficiency, more practical, larger scale. That's definitely one thing I would like to see. And I think is already happening, but is going to exponentiate over the future. I would say it depends on the climate. A lot of subtropical climates, I mean, it's easy to create much more food on that, because you usually have much more topsoil available. You have other plants that can really grow really well in poor soil, like things like cassava, like bananas, like things like that, that really can offer a lot of food, but it's a little bit more difficult in the Mediterranean climate. Honestly, for me, I can see that, yeah, animal integration is really important, I think, in the Mediterranean. Um, but yeah, I mean, the food that you're going to produce, how much you're going to produce, that also is going to depend on the succession of the soil at a given time and how you manage. So yeah, definitely the thing is you're going to be able to achieve more food than just like not planting anything. So I mean, obviously, but it's just like it's all about efficiency. Actually, it has a lot to do with efficiency and the succession of the soil. So yeah, I mean, you got to plant what works in that succession of the soil. That's really important. And yeah, when you're dealing with depleted land, you cannot expect as much food as you would with land that is already fertile. But over time, yes, you're gonna achieve that. And maybe in beginning years, it might take more. You wouldn't produce that much, but then over time, when you look at it over like decades or even like 5 years or even over generations, like you're gonna be able to produce much more food. And we need to think as well that the benefit is creating food now, but it's also creating food for the future via the topsoil that we create. So, for an example, let's say we don't want this plantation anymore. We want to plant an orchard instead, and then it ends up being an orchard like barely syntropic or anything. But by let's say that happens in 20 years, imagine the amount of topsoil that will be created. It could be a massive amount that then would allow much more food to be created in that spot because of the conditions there. So it's really important to think long term on it, more of a food resilience rather than just cash crop and food right now. I mean, of course, that's very important too, but we need to get into a new paradigm where we understand the resilience of having topsoil in place, and that is the real food actually at the end of the day. That's what actually is the battery charging up your trees, basically. It's like, without that, what can you achieve? Like, no, when there's desertification happening and it becomes a desert, what do you end up producing in the end? So it's really important to take that into consideration. And definitely there's a lot of work to be done to make it more efficient, intercropping of more like perennial plants or even annual plants, because by having this intercropping of, let's say, annual plants, okay, maybe this is going to be a bit of tilling, it's going to be some more inputs, but we reduce that significantly compared to other cultures, and we are able to benefit from the shade of the trees. We are able to get some crops on top of that, certain like fruit trees and things like that. So yeah, but it depends a lot on the climate, I must say. Find me on Instagram, there'll be a link below that video, and I share a few shorter reels there on Instagram. And also on YouTube, I would like to put on more of this educational content too, and also offer more of a progression of what's happening. And definitely in the future, I can imagine more larger scale systems being done in the next few years that I would like to take part in. So if you want to follow the journey, just give it a thumbs up, a like, and just subscribe, and you'll be able to get a lot more of these videos that are like educational or like progress over what I'm doing, basically.